Good evening, everyone. This is an introductory class to spectroscopic technique. The first thing we have to know is about electromagnetic spectrum. An electromagnetic spectrum, which I can probably denote with EMS. Electromagnetic spectrum is the spectrum of rays which coincide or interact to give the white light. So in the electromagnetic spectrum, you have different rays of light, some of which include gamma ray, visible light, infrared, microwaves. Now these are some of the components. Now these are some of the components light in the world, or let me say radiations in the electromagnetic spectrum. And all of this because they are rays, so we can describe them to be a wave. And we must know that waves have two basic property, which includes wavelength and frequency. So because they are waves, we can each of them has its own wavelength and its own frequency. Some of them have high frequency, while some of them have low frequency. For example, X-ray gamma ray has a very high frequency compared to this ones, which has lower frequency. At the same time, S3 gamma ray have shorter wavelengths compared to these ones which have longer wavelengths. So in a way, S3 gamma ray and visible light they tend to have much frequency compared to the ones below. And those ones that have more frequency are those ones that have shorter wavelengths. And what does this tell us about the energy of this light? As long as you have higher frequency, that implies that you're going to have more energy. And as much as you have low frequency, it implies that the rays of light being talked about have low energy. So I could say H3 gamma rays are high energy rays in your electromagnetic spectrum compared to your infrared microwaves and radio waves. So first, let me say basically, for this study, we must know some of these rays and their frequency and wavelength property to know which one has higher energy, higher frequency, and higher wavelength. And in the other way, which one have lower energy, low frequency, and probably low wavelength. That's very easy for us to know. But at the same time, we must also understand the relation between energy of these rays of light, their frequency, and the wavelengths. And that goes to the formula which you might have known before, or probably do not know, which is T equals to HF. So E is the energy of that particular light you are considering, is the Planck constant, and F is the frequency. So it implies that if I know the frequency, I could easily get the energy of that particular ray of light. At the same time, your energy can also be equal to hc over lambda. Like I said, each of these rays of light can be described in terms of frequency and also in terms of wavelength. So this is the formula that relates frequency to energy, and this is the formula that relates wavelength to energy. So we can say that energy is directly proportional to frequency, while it is inversely proportional to the wavelength from these two formulas. So in a way, they can always give us frequency of a particular um, ray of the electromagnetic spectrum and ask us to determine its energy. At the same time, they can also give us wavelengths and also ask us to determine the energy of that particular ray of light. Let's note that the C that is written here implies the velocity of light, which is 3 times 10 to the power 8 meter per second. So with frequency or with wavelength, you can easily calculate the energy of any given ray of light. And that's the importance of this formula. But more importantly, because our focus is about spectroscopic studies, much focus will be placed on wavelengths on light of light for different spectroscopic techniques that we're going to be considering. And for this particular study, the major kinds of the major parts of this electromagnetic wave that we're going to be looking at for spectroscopic studies or for spectroscopic techniques includes your includes your UV, which is your ultraviolet and visible region. We also look at the infrared region of the electromagnetic spectrum. We also look at something that we call the nuclear magnetic resonance. It's also a wave, but it's of higher, it's of lower frequency, or you can say of higher wavelength. I think those are the major ones we are going to be looking at for the sake of this course. And I hope that we'll get to understand some of the things that we want to know.